This question comes from Sarah, who asks, what's the deepest hole we could dig before hitting something strange? To answer this, we first have to agree on a few things. First, what counts as strange? For our purpose, let's define strange as anything that significantly impedes our digging progress or fundamentally changes the nature of the challenge. This means hitting simple, normal granite is not strange. Hitting a pocket of natural gas, while dangerous, is also not technically strange. Hitting the Earth's mantle, though, where the rock starts flowing like a weird, slow-motion river. Now, that is starting to get strange. Second, we have to define what counts as digging. We're assuming we have the best, most advanced conventional drilling equipment available, like the kind used in deep oil and gas exploration, but we're not using sci-fi melting rays or matter phasing tools. This is a hole, not a wormhole. So, where do we start? Well, we already have a record. The deepest man-made hole in the world is the Kola Super Deep Borehole in Russia. It took nearly 20 years to drill, and when it finally stopped, it reached a depth of 12,262 meters, or about 7.6 miles. To put that in perspective, the deepest point in the ocean, the Challenger Deep, is only about 11,000 meters. The stickman on screen waves down at a tiny hole. This deep hole was stopped not by finding aliens, but by two very unstrange, yet very effective obstacles: heat and pressure. At 12 kilometers down, the drillers expected the temperature to be around 100 degrees Celsius, a bit warm but manageable. Instead, they hit temperatures of 180 degrees Celsius, 356 Fahrenheit. That's because as you go deeper, the heat from the Earth's core gradually radiates outward, and the rock itself is simply hotter than predicted. At the same depth, the pressure was enormous, enough to turn normal rock elastic and flow like plastic. The drill bits would just spin uselessly, the rock closing in on itself. The deepest point ever reached by the drill was an entire mile short of the original target. The stickman tries to push a melting stick into the ground, but the ground just absorbs it. So, if we upgrade our equipment, how much further can we go? To break the Kola record, we have to tackle the heat. We could use experimental liquid metal drills or circulation systems that pump freezing fluids down the hole. Even with these extreme measures, the thermal gradients, the rate at which temperature increases with depth, is our absolute enemy. Scientists estimate that even the best conventional drilling technology would max out at about 15 to 16 kilometers. At this point, the pressure alone would crush the steel drill pipe like a soda can, and the temperature would vaporize most lubricants. That's our maximum depth before the drilling environment itself becomes strange. But let's assume we invent a drill that can withstand infinite heat and pressure. We are now limited by geology, and our next strange landmark is the Moho. The Moho, short for Mohorovičić discontinuity, is the boundary between the Earth's crust and the underlying mantle. This is the official point where the material below us changes fundamentally. The crust is made of familiar stuff like granite and basalt. The mantle, which starts anywhere from 5 to 70 kilometers down, is made of an entirely different composition of dense, iron-rich silicate rocks. In some places, like under the ocean, the Moho is only 5 kilometers deep. Under the continents, it can be up to 70 kilometers. Let's pick a thin spot under the ocean, say 5 kilometers, and assume we succeed where all others have failed. We break through the crust and into the upper mantle. The stickman finally breaks through a small layer and lands on a giant blob. We are now truly in strange territory. The mantle isn't liquid magma, it's a solid, but it flows incredibly slowly over geological timescales, a process called convection. Digging here is less like drilling through rock and more like drilling through something that is technically solid but moves like molasses. The rock is so hot and under such extreme pressure that its crystalline structure is unstable. The mantle is constantly circulating, dragging plates of the crust around and causing earthquakes. If your drill bit stops spinning for even a second, the strange viscous mantle rock will simply engulf and seize it. If, by some miracle of engineering, we manage to drill all the way through the upper and lower mantle, which is about 2,900 kilometers thick, we hit the ultimate strange destination, the outer core. This boundary is defined by the fact that the material suddenly becomes liquid iron and nickel. The stickman is suddenly swimming. This liquid metal is churning, superheated, and is what generates Earth's entire magnetic field, which protects us from solar radiation. Your drill bit, even if it could survive the